estimation and decision. Since I am not enumerating the whole population, but I am taking a sample. So when I am estimating something, it may be little bit plus or minus or somewhere in the network of true reality. My estimated value and what is the true reality. There may be some amount of difference, and that difference will be error in my estimation from the reality. And if that is under my acceptance, this will enable a decision process. If it is not under my acceptance, this will also enable the decision process. In whole decision process, there are two types of error happen. We will discuss it in later slide. Power, precision and tolerance limit. This is very important in sample size calculation. How much power you want. Power is basically ability to take a correct decision from a manufacturer point of view, sponsor point of view. So if your drug is working, you must have to show it is working in your sample, in your research. And that ability is the power. So you have to decide how much power you want. Then precision is like true reality. And how much deviation from true reality you are going to accept. This is also known as tolerance limit, means how much you can tolerate a deviation from the true reality. Another aspect is validity and reliability. So once you repeat the process and you get exactly the same, this is the reliability. But in your whole research process, if you are going to be closer towards the true reality, it's the validity. In statistical process or in statistical computation, there are statistics involved. We call T, F, Z, chi-square. There are so many. So this is also a very important aspect. Like your whole estimation or whole hypothesis testing is going to use a particular statistics. And if we know that, then that will enable us our sample size calculation problem. Now, once we decided our objective, we made the framework, we proceeded with what kind of data we want to collect. So, in this slide, we will try to understand the attributes of the data. So, in this slide, we try to understand the attributes of the data. Like what kind of data? Why this is important? Because the statistical treatment, use of statistics are very, very different from one kind of data to another kind of data. Data are basically two verticals. One is qualitative, another is quantitative. If you go in qualitative data, again there are mainly classified two verticals. One is nominal and one is ordinal. So in a nominal, it's only the attributes like color of our body, white, black, or gender, male and female. There is no one superior, there is no one inferior. It's just an attribute, nominal. But there are another type of data. There also you cannot measure exact magnitude, but you can say that which one is superior than which one. So like a disease, there are conditions like mild, moderate, severe. Here you can see that disease is progressing from mild to moderate to severe. And you understand which one is more, which one is lesser. So such kind of categorical scaling or quality, which is in some amount of order, is come in ordinal scale. And then the main pillar of data is quantitative. We can measure it on some scale. So in a scale, there are numerical measurements, there are interval scale or ratio scale. More detailed classification of the scale can be discuss further. We'll see later how it is. Now, once the data is collected, what to do with the data so that my decision process can be streamlined. Now, data is not going to help until you are going to operate with the data, get the extract out from the data. So, what you can do? You can first identify the central tendency of the data, where the kernel of the data is lying. What is the central point of your whole data? Now you take some variables and then to identify what is the central tendency, there are mean, median, mode, you can estimate and find out what is the central location of your data. Now once you know the central location, then you have to figure it out from the central location, how far away the data are lying, individual points are lying from the center, how far away. And this will measure the dispersion from the central, how dispersed your data is. You can measure its range, interquartile range, AST, variance. So many statistics is there to evaluate it. So many statistical operation is there to understand the dispersion. Now you know your central tendency, you know the dispersion. Then you want to know whether your data is normal or not. So compared to a normal bell-shaped curve, if your data is slightly different than that curve, it means the shape is some different from the bell. And to measure that, we have skewness and kurtosis. So once the bell-shaped curve is too much peak or too much flat, or tilted towards one direction or another direction, these two measurements, skewness and kurtosis, are going to help you to understand the normalcy or deviation from normalcy of your data. Now you have collected the data. There are several variables you want to understand which one has impact on others, what is the relation between two variables, whether they are dependent, independent, all those interdisciplinary understanding between collected data. Statistics here also can help to understand it by correlation, regression, or some kind of modeling, estimating sometime hazard or understanding the ratio, risk, so many things. I have listed a couple of things here, but there are much more here. So it will depend on your objective, what you want to measure and how you want to proceed. Then there are one more concept like strength and accuracy in measurement. So whatever you are going to measure from your data, how much accurate it is. So in that, we have some kind of confidence interval approach. So we build an interval and we say that, yeah, we are 95% sure that actual value will lie in between this band. With the nominal and categorical data, we can go ahead with the count, frequency, and percentage option also. Now I would like to let you walk through with me to understand reliability and validity concept. So I have put here, please focus on my cursor. This is my population. Okay. So individual data lie somewhere in this population. What is the central value of that data? Central tendency is here for this population. Okay. Now there are 4 group of researcher has been asked to perform a survey in this population and tell us that where is the central value. Okay. Now I have copied this circle and pasted it 4 times. 1, 2, 3 and 4. Group 1 researcher, 2, 3 and 4. There are 4 group of researchers. So this group went and identified that your central value is here. He has collected our data, surveyed the population and he found data is lying somewhere here, central value is here. Now you can see that he is quite closer towards the reality, true reality, population reality. But his data value are spreading somewhere this direction, then far away here, far away here. So what I can say that maybe this researcher obtained a quite valid result, but I'm not sure if he will perform another survey or any other group will perform the survey with the same methodology, he will reach here. So there is slight reliability lack here. Now see what other group is doing. So he has also collected the survey in the same population. His data values lies here. Now see how dense his data value. It means that if he conduct the research next time or he do the survey next time, most possibly he is going to be in the same circumference. So he is quite reliable. Every time he is going to get the same value, but far away from the true reality. So his validity is under question mark. Now see, group third, he has the data value all over there. He has a concern on reliability also and then validity also. Far away from validity and then reliability is also a concern. This group 4 is precisely targeting the true reality, means valid and then very close in the circumference, means he is valid also and reliable also. Try to understand, all are performing their survey in the same population. So it's their methodology or their sampling framework, or there may be some kind of different approach they have obtained, and that's why their result has some concern. Someone has a validity issue, someone has a reliability issue, someone has a both issue. Now this circle I have drawn to understand that precision and tolerance limit problem. So if you can see that this is the true reality and you want to estimate this parameter in your sample, how closer you want your estimate from this true reality. So let's put a circumference here. Now if I want my estimate from the sample should be within this boundary, very close towards the reality. Maybe I need a very bigger sample size, but my precision will be very high. I am very, very precise to the true reality. Now if I would compromise with the precision and I say that okay, even I will get the result somewhere in this circumferences, I am okay. I have sufficient knowledge to understand the population central tendency. So then I have compromised little bit with the precision. My sample size may reduce. So you can understand here that how much important precision is